Please make him welcome.
Thank you. My name is Adam. You might remember me from such talks as the one I finished giving 7 minutes ago. And now for something completely different. I spend a lot of my time working with C and C++ and Rust code bases, and particularly when dealing with the C and C++ ones. I often find that I get a lot of questions along the lines of, how did you find that memory leak? How did you find that locking issue? And why are you so good? To which the answers are basically Valgrind, and I'm not, but people work on Valgrind. So in the interest of spreading the gospel of Valgrind just that little bit further, I am very quickly going to run through a couple of demos showing why Valgrind is awesome and why you should basically accept it as your Lord and Savior, particularly if you're writing unmanaged code. So I might. Actually, I don't, but this is just too funny not to. Okay, thank you. No. Okay. There's a reason why I did all this as makefiles. Okay, so let's look at a just really simplistic C example. I wrote this code. It is about my usual standard. There's an include file that doesn't even need to be there. But basically, if you hubless C, then there is an alloc function, and mysteriously this is leaking. I don't really know why. So let's say that we're going to run this through Valgrind. Now, shift purge up. Okay, so basically I ran this through Valgrind. So Valgrind, what it does is basically it runs your program on a fake CPU and fake memory, and then it tracks what the hell happens. So it's got a leak checker. By default, it runs this tool called memcheck. It has a whole bunch of tools. It can detect memory leaks, and you will note, if I scroll back down, that it tells me that I leaked 4,000 bytes of memory, probably because I forgot to call free after my calloc. And it even told me that I leaked another 4 bytes of memory, presumably because of that string duplication there. If you compile with debug symbols, it gives you the actual lines of code, it gives you the source files, and basically you have everything you now need to fix your code. So, leak checking, it is good. Let's look at another thing it can do. So, okay, so I fixed my problem. I put a free in. That's basically perfect code, right? Nothing could possibly go wrong. So, let's see what Valgrind thinks of that. Valgrind is telling me I have an invalid write, probably because I freed and then actually wrote to the array that I had just freed. So invalid write, it even tells you where you freed your code, or where you freed that block of memory, which is super useful. This has literally bailed me out of shipping multiple brown bag bugs in the last few years, so highly recommend it. Okay, let's press on because I'm already 3 minutes in. Okay. That is the same code. How interesting. Let's see what it does. Ah, right. So you can also tell it to connect to a GDB session, or you can start a GDB session, and if it detects one of those errors, it will basically break your GDB. Now this is going to be extremely tricky to do because I'm kind of looking over here. Where's my mouse pointer? There it is. Okay, so GDB off by 1. I have this whole mess of stuff that I now have to copy and paste in. Okay, continue. Okay, and it breaks. And the reason it broke, if I go back to the Valgrind one, is because it detected that invalid write. And now I have a GDB session running with that code running, and I can do, whatever I need to do. There's not much of a backtrace because we're in main, but I can do whatever I need to do at this point. And everything is great. Okay, that's good. Now let's do something a little bit harder. Let's go to C++ land. This is actually entirely because I can't remember the pthread API off the top of my head. But let's look at this. So we've got 2 threads being spawned. We're pushing stuff into the attendees vector, blah, 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 blah. There is a fairly obvious problem here, which you can kind of see, which is that we're reusing the same vector in 2 places. There's no locking because YOLO. And if I run it under this tool called DRD, which is a data race detector, there is just a ludicrous amount of backtrace. And this is partly because C++. But you can also see there that address is at offset. I actually need to find the error message. Jeez. Okay, here we go. Conflicting load. So what it tried to do there was it's tried to load the vector because but the vector's also in another thread, and then it's got like the stack traces for both of the threads below that, telling you where the conflict actually happened. And I believe I'm now out of time, so thank you very much. Use Valgrind.
So we still have time for like 2 more lightning talks if you have more demos of Valgrind.
I can just come back.
Oh, hi Brenda, how you doing? Hey, it's in my hand and I'll pass it to you in just a moment. Brenda Wallace, everyone.
Kia ora. Ngā mihi ki te tanga whenua tēnā wahi. Kia ora, my name is Brenda. I work for a part of the New Zealand government that's too complicated to explain, so I'm going to hand wave. Hi. So, there are lots of rules that are inflicted on us in our day-to-day lives. For example, law, legislation, regulation. Many of these are dreamed up by lawyers and parliamentarians, and they write them down in something that resembles English. And then a bunch of people, many of them in this room, at the end of this long waterfall chain, now have to implement it. For example, how much tax should you pay? How much holidays do you have? Do you have an unemployment benefit? If so, how much? So you end up with a software engineer trying to work out what exactly is the number at the end of this complicated formula described in legalese. And guess what? We all do it differently. There are at least 30 implementations of the Holidays Act working out how much holidays you get, and they're different. So this is not a great process. There's no feedback loop, there's no unit tests. So we decided to do something better. We decided to do something a bit fairer, and we decided to do, when we publish law, we publish a reference implementation in Python. Ooh, mind blown? Okay. It's not official. I haven't put a gov domain on it. I'm just putting it out there to see what you think. Not only do we publish it in Python, we add unit tests. If you are a single mother who is unemployed with 3 children, 1 has a disability, your amount per week is this. And then we run the code and see if it comes up with the right number. And then when they change the law, we change the code and we point out all the numbers that changed. Like, did you intend to make it $0 if they are a lesbian? I don't know, making something up. Yeah, and like, oh, we didn't think of that scenario. Well, you should these days. So the unit tests fail and they regress, and we tell them that you're changing these numbers for these people. For as much as we have test coverage, that is, we haven't got everything. I'm going to give you the URL to my test bed, and it's on a $7 Heroku, so you'll probably break it, but it's on rules.nz. which is a provisional name because I had to think of something. And what we do is we also publish it on GitHub. So if you see something that's wrong, you can send me a PR and then I'll go find my lawyers and some money and see if you're right. But you can also download it yourself. We ran a whole server, so it's an API. If you want to calculate your working for families, and oh my God, that formula is very, very complicated. If you want to calculate your working for families, tax credit, payment, something, something, and work out if that's more money than your paid parental leave when you're making a decision, you can just run my code. You can read my code. And if you want, you can go run it on your own server and calculate it in private. If you are a person who works at a bank or something like that, or an accounting software place, you can take my code and run it instead. And you don't have to run the government's version of it. And you can also, if you have the government inflicting a formula on you, working out this is how much income tax you should pay, this is how much you should get, you can say, show you're working, and go to my GitHub. Thank you.
Thank you, Brenda. Thank you.